Hey guys, this is Mrs. Munyon, and we're going to think about the term absolute value today and what it means. Absolute value is represented by two straight lines or bars, like this, 1, 2, and you'll find a number in the middle of them. And it means absolute value. Absolute value means how far from zero. How far from zero. Okay? It does not indicate direction. Absolute value doesn't say in which direction from zero. That's a C. It doesn't indicate direction, only how far. Okay? So I could walk 1 mile from the school in one direction and 1 mile from the school in a different direction. Both would be 1 mile from school. So if I said I walked 1 mile from school but didn't tell you where I went, you would only know how far I walked, not where I went, right? So that's what absolute value is, all right? And we will eventually get to thinking about where absolute value fits into PEMDAS, and it would be here with parentheses. So it would be one of the first things you solve before you finish working through an equation. Now, so in today's lesson, we're thinking about how to represent absolute value on a number line. Absolute value on a number line. And we're also thinking about how to write absolute value as a number. Okay, how do we do those things? So let's first continue thinking about what it means when we say how far from zero with an example like the school here. And here it says, let's say the house is at 0 on the number line. And each mark on this number line equals 1 yard. So each mark equals 1 yard. Okay? Oh, that was interesting. I've never had it do that before. Draw a tree 3 yards west of the house. So if we draw a tree here, here's my tree. I'm not going to get too super excited about being an artist right now, just getting that job done. Okay? And then east is in the opposite direction, right? And it says draw a mailbox. So here's my post and my super not fancy mailbox. You know, I don't know if you guys have mailboxes where you live. They're becoming less and less common, but when you put the flag up, it tells the mail carrier that you have mail that he needs to pick up. So the distance between the house and the tree is 1, 2, 3 yards. And the distance from the house and the mailbox, 1, 2, 3. Okay, so they're each 3 yards from the house. So they're equal. The distance is equal. They're both 3 yards away. Okay, and the tree and the mailbox are in opposite directions. Just like the opposite of up is down, the opposite of 3 east and 3 west is opposite. They're opposite directions, but the same distance. So how does a number line above help us to understand absolute value? Well, for one thing, we can think of the house as at 0, right? The house is the same as 0 on a number line. And the tree and the mailbox are the same distance from the house, but in opposite directions. So we can see how the same distance can be in opposite directions, can be in opposite directions. And again, as we get into absolute value, we are going to realize that it's only indicating distance. It has nothing to do with direction. Okay, so let's try this real world link. It says Jesse leaves home and walks 4 blocks west to the grocery store to buy milk. So here's home. And he goes 4 blocks west. So, let's think about that for just a second. So if this were a compass, north is up and south is down, right? Okay, east is this way and west is this way. And in real life, we know where north is. That's towards Reno. So if you take your body and face north, and then you think about where the ocean is, which is up and over the Sierra Nevadas, that's to your left when you're facing north. So you can always figure out your directions. If you know where north is, face north, west is to your left. Just remember where the Sierra Nevadas are when you're facing Reno. Okay, so west is this way, and it says 4 blocks. 1, 2, 3, 4. And what is that? That's the grocery store. Okay, so we'll draw a bigger building, I guess. That's the grocery store. And then he walks another 4 blocks east to the post office. Then he walks another 4 blocks east to the post. Oh, after he goes home. He returns home. 4 blocks east. 1, 2, 3, 4. And here's the post office with their big American flag. Okay, so the post office and the house are both 4 blocks from home, but in opposite directions, right? Okay, so you could write, they are the same distance. The post office and the house are both 4 blocks from the house. Oh, did I say that? The post office and the grocery store. This is the grocery store, okay? They're both 4 blocks from the house, okay? But in opposite directions. Opposite directions. All right. So again, absolute value is how far, but not in what direction. Okay, so let's find opposites. There's some funky thing in here, so make sure you're paying attention to this. Let me go to my highlighter. Positive numbers such as 2 are always graphed to the right, positive, to the right or above. So sometimes, like if we're talking about temperature, our number line might be up and down. So 0 would be here, these would be the positive numbers, and these would be the negative numbers, as opposed to a number line this way. 0, these are the negative numbers, and these are the positive numbers, okay? Opposites are numbers that are in the same distance from 0, but in opposite directions, okay? Same distance from 0 in opposite directions. Since 0 is not negative or positive, 0 is its own opposite. So if the book actually asked you what's the opposite of 0, you would say 0, okay? Now here's the part I really want you to check in with because it's a new concept. It's a tongue twister. The opposite of a number is the number itself, okay? So for example, if we asked for the opposite of the opposite of 3, okay? So first we think about the opposite of 3 is negative 3. The opposite of 3 is negative 3, but then if we want the opposite of that, that's 3. Okay? So the opposite of 3 is 3. So it's the same number. So it's like you just keep spinning around till you're dizzy and you fall down. Okay? So I want to highlight this. Okay, the opposite of 3. The opposite of 3. The opposite of 3 is negative 3, but the opposite of 3 is 3. Goodness. So let's look at the examples. Find the opposite of negative 5. So if negative 5 is right here, the opposite would be 5 in the positive direction. So the opposite of negative 5 is 5. Okay? Now find the opposite of 4. Well, the opposite of 4 is negative 4. That's right here. Negative 4 is right here. So the opposite of negative 4, which would be the opposite of 4, is 4 in the positive direction, which is 4. The opposite of the opposite. Okay? So what is the opposite of 3? Well, that would be 3 in the negative direction, which is negative 3. And then the opposite of negative 2. So first, the opposite of negative 2 is 2. Then the opposite of 2 is negative 2. So the opposite of -2 is -2. They're going to bring that up a few times, so keep getting used to that tongue twister, basically. Let's take a look at absolute value again. Remember that absolute value is how far from 0, irregardless of the direction, okay? So -4 and 4 are both 4 spaces away from 0. So the absolute value of 4 is 4. And the absolute value of -4 is also 4 because they are both 4 units from 0. All right? The integers -4 and 4, remember an integer is all the positive and negative numbers, are each 4 units from 0, even though they are on opposite sides of 0. So the absolute value of -4 is red, is negative. The absolute value of -4 is 4 because it's 4 spaces or places or units or yards or miles or meters from 0. Okay, so let's evaluate or solve the absolute value of -7. Well, -7 is 7 places or units away from 0, so the absolute value of -7 is 7. Ooh, what if we create an addition sentence? Let's take a look at that. It says the absolute value of 5, which is 5, plus the absolute value of -6. The absolute value of -6 is 6. We add them. 5 and 5 is 10, plus 1 more is 11. So the absolute value of 5 plus the absolute value of -6 is 11. That's kind of cool, huh? Let's try another one. Oh, and that's where the PEMDAS comes in, because remember we solved the absolute value first. Parentheses or absolute value brackets, exponents, multiplication and division, addition and subtraction. Okay, so let's try number 5. The absolute value of -7 is 7 minus the absolute value of 3, which is 3. Subtract them, and we get 4. So that's 7, take away 3 equals 4. All right, let's try some more. The absolute value of 14, that's 14 units away from 0. Now let's solve this one. We'll do the absolute values first. So the absolute value of -9 is 9, and the absolute value of 3 is 3, and it says to add. 9 and 3 is 12. Okay? And E, the absolute value of -8 is 8. The absolute value of -2 is 2. It says to subtract. 8 take away 2 is 6. Okay, let's move on. Ooh, another example. Okay, so this one, a seagull is flying 25 feet above sea level. So if this were sea level, right here, that would be 0, right? So let's draw this out. Here's 0 on our number line. Positive numbers are up, negative numbers are down. Let's keep going. So 5, 10, 15, 20, 25. Here's 25. There's our seagull. Okay? And Nevaeh is diving 15 feet below sea level being 0. So 5, 10, 15. Here's our diver. Okay? 15 feet, negative 15 feet, because it's below 0. Okay? And the question is, what is the distance between Nevaeh and the seagull? So we need all of this distance, plus all of this distance. We write that as the absolute value of 25 plus the absolute value of 15, when absolute value of 25 is 25, absolute value of -15 is 15. When we add, we get 40. Okay? So the distance between the seagull and Nevaeh is 40. Is it in feet? Feet. Okay? Oh, what is the opposite of 0? Oh, well, 0's really nothing, so the opposite of nothing is nothing. So that's 0. What is the opposite of the opposite. So here's that funky one. The opposite of the opposite is 6. So first let's find the opposite of 6, which is -6. And the opposite of that is 6. So the opposite of 6 is 6. Okay? Now let's evaluate these expressions. So this says the absolute value of -5, which is how far from 0? That's 5. Now we have an equation. The absolute value of 20 is 20. The absolute value of -3 is 3. It says to subtract 20, take away 3, 17. And another, the absolute value of -16 is 16. The absolute value of -12 is 12. It says to add. So that's 10, 20, 26, 27, 28. Good. Okay, now for the word problems. A game show contestant lost 15 points. That's -15. He answered another question incorrectly and lost another 15 points. Another 15 points lost. How many total points has he lost? So we know total means add. So we're going to add these. Okay? But we really just want to know how many points he lost. So we're going to take the absolute value of each of these. So that's 15. And absolute value of this -15 is also 15. We add them. So total equals 30 points lost. Not going well for him today. Hope he didn't gamble on that. Building on the essential question, how can absolute value help you to understand the size of a quantity? Well, if we know how far from 0, what if we were talking about money? What if instead of points, he had spent $15 and then he spent another $15? Well, now he has $30 less, right? So maybe it shows you how much in debt you are, how much you've spent. Or if we're talking about money we owe someone, we borrowed $15 from mom and $15 from dad, then we owe $30, right? How much you've spent in all. Okay, so gives us a way to think about negative, okay? Or what if it's from the time I woke up to now, the temperature has dropped 5 degrees. And then at night, it dropped another 10 degrees. So now it's 15 degrees cooler than when I first woke up, right? Okay, so it's a way of thinking about numbers in a certain direction that helps us to understand that. All right, so go try some on your own. Remember to refer back to your notes about the opposite of opposite so you don't get mixed up. First, find the opposite of the number and then the opposite of that opposite. I think that will help you a lot. But come ask questions if you need to. And remember, you can work together.